Okay, now revisions. We're going to see the Z transformation example. For example, if question give you Sn, uh, for example here 3 n's, 3 power of n, u minus n, minus 1. So first of all, if you got this kind of questions, you need to um, try to imagine what the signal is look like. For example, here I draw the signals. The u minus n represent of the left side of the signals, and the 3n is the amplitude here, continues with the n, and the n minus 1 represent of the signal start from the minus 1, and for the signal before the n minus 1, so we assume they have no signal generated. So means that what we can conclude here that the signal only happen at the left side. Means that from the minus 1 until to minus infinity. So let's go. We try to convert our signal time domain into the Z domains by implement the formula of Z transform. The Z transform said that we need to do the summations. If the plus, we do the integration. For the Z transform, we do the summations from the minus infinity to infinity Sn times Z minus n. So we copy back the infinite minus infinity to infinity, and then Z minus 1, and we put the Sn equal to 3n, 3 power of n, u minus n minus 1. Alright, now to simplify our systems, we already know that the signal start from minus 1 until in minus infinity. So u minus n minus 1 we can drop or eliminate by we set up our limit. So from the limit minus infinity to infinity, so we know the maximum is going to minus 1. So we adjust our limit to minus infinity to minus 1. So we can drop these equations. Then we left as 3n, 3 power of n, z minus n. So we can conclude that if we put the value here, we can rearrange like this: 3 power of minus 1 z1 plus 3 power of minus 2 z2, by replacing all the value here, and then we can rearrange back. To make more easy, we need to change our limit to positive side, so that's why we try to readjust this alignment to limit from 1 to infinity, right? If we adjust n minus 1, n equal to 1 until infinity, so we can conclude that 3 power of minus n z power of n. So to make you more clear, actually it's from, we can say that 3 power of minus n zn, right? From here we can conclude that. So to make more simpler, I bring out the n outside the bracket here, right? So we can say that if 3 power of minus 1 time of z, we can say that z divided by 3 power of n. Okay, minus of 1 here we can describe as the division, so z over 3. Okay, So from here we can conclude that because our signal at the left side, z over z divided by 3 must be less than n minus n minus 1. No, minus 1, less than 1. So we can conclude that z or the only signal happen uh, when the n less than 1, right? So it's okay, never mind. We just take from here. Okay, we know that our signal happen when n equal to 1 until infinity. So signal is z over 3 power of n. So still not normalized. If we do the normalize, so we need to start from n equal to 0. So when n equal to 0, we assume that the signal is 1 here, the amplitude 1. If we want to normalize from 1 and equal 1 to 0, so we need to put 1 here. So we can assume that 0 at n equal to 1 is 1. Then so we can start our limit from n from 0 until infinity. So 1 minus z divided by 3 power of n. Right. Okay. From our previous lecture, by consider the element of convergent power series, they say that if the infinity from 0 until infinity, n power of n, we can say that a power of n equal to 1 over 1 minus a, where the a less than 1. So that's why by consider this formula, so we need to transform our signal into n equals 0 until infinity. And then the z divided by t power of n, we can use the rule of power series here. So we know that a power of n equal to 1 over 1 minus a. So here we can say that z divided by 3 power of n equal to 1 over 1 minus z power of z divided by 3. Alright, to make more easy, I want to eliminate this element of 3. So I need to time with 3 for numerator and denominator. So I got the 3 over 3 minus z. Alright, now we have 1 in front. So to make a unity or combine of those elements, so we need to get the similarity of denominator. So it becomes 3 minus z divided by 3 minus z, um, minus 3 over 3 minus z. So by same the denominator, so we can add and subtraction directly. So 3 minus 3, so minus z, and become is minus z 3 minus z. So to make a more to know more form, suit with the tables, z transformation table. So we need to eliminate the minus z here. So but we time with minus 1 numerator and denominator. So and the result we got the z over z minus 3. So we can conclude that um, uh, z minus 3 must just length n equal to 1. So signal only happen when the n less than 1. So we can conclude that z uh, must be less than 3 when we brought the 3 to the right side. So z less than 3. So signal only happen when z less than 3. So from here we can identify the element of poles and zeros. The poles came from the numerator when we set the z minus 3 equal to 0, and then we bring the 3 to right side to we know the z equal to 3. And however for the zeros is z z equal to 0. So from here, we can plot the ROC and the z-plane. So we have two circles, one the outer circle and the second one the unity circles. The amplitude here should be 3, right? And we have another circle here is amplitude 1. You can say that unity circle, right? These are our poles at 3, and we have another plot 0 here as a 0, right? From here, we can shaded our ROC. It because the consideration is less, the signal at the left side, the signal only happen at the left side, that the original signal. The original signal is happen when the left side. So when the signal the left side, so we need to shade it inside the circle. Okay, by refer to our lecture note. When when the signals z less than a, so means that the signal at the left side, so we need to shader inside the circle. So when our signal at the right side, so means that z more than a, so we need shaded outside the circle, outer circle. So that is different. So this signal at the positive side, so we shaded outside the circle, or the outer the circle, for the condition when the signal less than a. So at the left side, we need to shade it inside the circle. So for this exercise, we know that the signal at the left side, so we need shaded inside the circle. Right? That's important to we want to consider the system is stable or not stable. So we can say the system is anti-casual because the signal is the left side, so we shaded inside the circle. So means that the system is anti-casual, and the system is stable because we shaded um, inside and it touched the unity circle. So when it touched the unity circle, we can say the system is stable. So because pole is located inside the unity circle. No, the shaded area is located inside the unity circle. Alright. So again, I conclude that the system is anti-casual because this original signal is the left side, so we shaded inside the inside the poles. Then and then the shaded area touch the unit circle, so we can say the system is stable. Alright, that's all for these revisions for the Z conversions and also the stability and casual systems.